This is part equations of polynomial and rational functions. So what we're going to be looking at today is how to take a graph and come up with the equation that was used to make the graph. So in our instructions, it says determine the equation of each of the following functions. And in part A, we have a graph. I have two pieces of curve and I have a point that's marked with the coordinates 4 and 2. So anytime I'm looking at a graph, I do like to start by drawing in my asymptotes. So I'm going to try to figure out where the vertical, horizontal, and oblique asymptotes are. So this appears to have a vertical asymptote at 3, as well as a horizontal asymptote at -2. So from here, I'm going to think about what I use when I'm graphing. So when we make a graph, we use our x-intercepts, our y-intercept, our vertical asymptotes, our horizontal or oblique asymptote, and a hole if we happen to have one in the graph. So when I'm using the equation, I know that the numerator is where we get our x-intercepts from. So the top part of the equation is where our x-intercepts come from when we're calculating them. The denominator is where we get our vertical asymptotes from. So what I'm going to do is try to start by pulling out of the graph what my x-intercepts are, what my vertical asymptotes are, and then see if I can use that to put together an equation. So I'm going to start with my x-intercepts. And there is only one x-intercept right here at +5. So I know that I have an x-intercept at x equals 5. And I need to try to work backwards to figure out what the bracket was that gave me x equals 5. So I would subtract 5 from both sides to get x minus 5 equals 0. So I know that in my equation, I must have had an x minus 5 in the numerator because the x-intercepts come from taking the numerator and setting it equal to 0. I'm then going to look at my vertical asymptotes. We have a vertical asymptote at x equals 3. So my vertical asymptote is x equals 3. And we're going to do the same thing we did with the x-intercept. We are going to try to rearrange to figure out what our bracket originally was. So this is going to be x minus 3 equals 0. Vertical asymptotes come from the denominator, and what makes the denominator 0? So I know that there has to be an x minus 3 in my denominator. So what we're going to do is try to take this information and build the basic beginnings of our equation. So I'm going to say that my equation is y equals, or f of x equals, or a of x equals, because this is question A. I think I might just go for y equals. In the numerator, that's where our x-intercepts come from. There should be an x minus 5. In the denominator, there should be an x minus 3 because that's where our vertical asymptotes come from. Now, I would take a moment to think about whether there's an exponent on either one of those brackets. If there was an exponent on the numerator, the x minus 5, that intercept would either be a critical point if it was an even degree exponent, or a really noticeable inflection point. I don't see either of those, so I don't think there's an exponent on that bracket. In the denominator, the x minus 3 would have an exponent of 2 or 4 or 6 if the ends were pointing in the same direction. Now I notice on the left-hand side, the end is pointing down, and on the right-hand side, the end is pointing up. So I don't think there's a square or anything like that on there. There could be potentially a power of 3 or 5, but for now, I'm just going to say that there isn't an exponent. Ways that I can check to see if I have done this correctly. I notice that the degree on the top, that's x to the power of 1. The degree on the bottom, x to the power of 1. So they have the same degree, they have the same highest exponent, telling me that this should have a horizontal asymptote, which we have, right? If the exponent was bigger on the top, I would have an oblique asymptote. So that's just kind of a nice way to be able to check to see if I'm on the right track. Now, the only thing that I don't know is whether there maybe is a number in front here. So maybe there's a number in the numerator or a number in the denominator that makes my graph more stretched or compressed. So I do need to actually figure out whether there is one there. So what I'm going to do is add the letter K. Why K? That's the one that the textbook likes to use. It stands for a constant, although the word constant starts with C and not a K. So I usually put in some letter. The textbook uses K, so I use K. We're going to see if there's a number there, like a -1 or a +2 or maybe a 1/2. And we're going to figure that out by taking the labeled point from the question and subbing it in for X and Y. So you'll notice that there was this point here. It's not a hole in the graph. It's just a marked point. And this has coordinates X and Y. So one of the ways that we can figure out if there's a missing number in our equation that we don't know about is to take X and Y, sub them in, and then solve to see what K is. So I'm going to put 4 everywhere I see an X and 2 everywhere I see Y. So I'm going to get 2 equals K times X, so 4, take away 5, divided by X, that's another 4, take away 3. 4 take away 5 is -1, so I have 2 equals K times -1, divided by 4 take away 3 is +1. Now I have a choice at this point. I could divide -1 by 1 and then take that number and then move it to the other side. Or I could multiply by 1 and then divide by -1. So it's your choice. You can either divide these and then try to rearrange that number, or we could just start rearranging with these numbers. I think I might divide -1 by 1. -1 divided by 1 is -1. So I have 2 equals K times -1. And then I am going to divide both sides by -1. So 2 divided by -1 is -2, which tells me that in the front of that equation, there's going to be a -2 in front. So a -2 would make my graph a little steeper, and it would probably, because it changes the leading coefficient, take my graph and change it so that it either was facing up or facing down. It just flips the direction. So the last thing I need to do is take my x-intercept, my vertical asymptote, and my new K value and write my final equation. So my final equation is going to be y equals -2 times x minus 5 divided by x minus 3. Now, if you wanted to check your equation and see whether or not it was right, there are a couple of things that you can do. So option number 1, I know that I have a horizontal asymptote at -2. So you could multiply this through and see whether or not you would get a horizontal asymptote at -2. Another thing you could do is if there's a marked point or another point that you're reasonably certain of the coordinates of, you could try taking that point, subbing it in, like the number for X, and then seeing if you get the right number for Y. Just some different ways that you can check. So whenever we're doing a graph, find your x-intercepts. That's what makes the numerator. Find your vertical asymptotes. That's what makes your denominator. Compare and see whether there needs to be an exponent on any of those brackets. Check as a little check to see, would it have a horizontal or oblique asymptote? Do I have a horizontal or oblique asymptote? Make sure it matches. And then calculate to see if there's a number in front by taking the marked point and subbing it into your equation and solving. Okay, so I will see you in part 2 to look at example B.